7Es, receiving students and teachers. Thank you. You may sit down. All right, 7Es and receiving students. I remember giving you a homework. Receiving students, I told you to do one question for your homework. All right, so let's just go through that question together. Now the question was, you were to solve this problem, right? I walk at 5 kilometers per hour. How far can I walk in 3 hours? All right, good. We'll have Evelyn.
"15 kilometers per hour."
Okay, thank you, Evelyn. Do you agree with her answer, class? Who disagrees? Hands up. Okay, good, a number of hands. All right, she said 15 kilometers per hour. Do you agree with that? 15 kilometers per hour. What does per mean? 15 kilometers every hour. One. Okay, per means every, one, all right? Is she correct in saying per hour? Okay. All right, what should it be, class? 15 kilometers in 3 hours, okay? Because the fixed rate has already been given, 5 kilometers per hour. So every hour she walked 5 kilometers, okay? I walk 5 kilometers every hour. So if I walk in 3 hours, how many kilometers is that? That's 15 kilometers. So 15 kilometers in 3 hours. Okay, class, remember that. So 5 times 3 will give you 15. So 15 kilometers in 3 hours. Now the next recapping exercise, if you were to simplify this rate in its simplest form, 70 grams for 10 cubic centimeters, what will be the simplified rate or the fixed rate? How many grams per cubic centimeter? Receiving students? If you are to simplify this rate, how many grams will it be per cubic centimeter? Okay, Begley?
Seven is to 1 per cubic meter.
Okay, thank you, Begley. Okay, Begley said 7 is to 1. Now you're putting in ratio, ratio into rate. Okay. Come on, class. 7 is, we looked at this yesterday. We looked at some of these exercises yesterday. When you simplify it, all right, if we were to simplify, okay, I'm going to divide, just like when you are dividing ratios or you divide fractions. Okay, class? So I'm going to divide these two numbers by 10. All right, class, by 10. So 70 divided by 10, 10 divided by 10. So what's 70 divided by 10? 7 what? Grams per cubic centimeter. Okay? 7 grams per cubic centimeter. So we want to get the rate, the fixed rate. So 7 grams per cubic centimeters. So if it's 10 cubic centimeters, we are multiplying by 10. 7 times 10 is 70 grams. Okay? All right, so I reminded you in our previous lesson that it's rates. You can simplify rates just like ratio, just like fraction. You can simplify and come up to the fixed rate. Okay, in today's lesson, we're going to be looking at comparing rates. Okay, now just recapping on our previous notes or points, class. Rate is when we are comparing two unlike quantities. For example, in the video insert, you saw toyas per liter. Okay, those are two different quantities. Toya per liter. All right, kina per kilogram. Okay, so you are converting, so not converting, but you are comparing two unlike quantities. Now again, rate is expressed as a quantity per unit of another quantity. Okay, class? All right, in today's lesson, we are going to compare rates. Okay, in order to compare rates, class, when we are comparing two rates, both rates need to be in exactly the same units. All right, if we want to compare two rates, we must make sure that the rates, they need to be in the same units, okay? So it will be easier for us to compare the rates. All right, I'll give you one example. Okay, we have a question here, right? Which speed is faster, class? Okay, the answers are A, 9 meters per second, B, 60 meters per minute, and C, 36 kilometers per hour. All right, they are different rates. Now we cannot compare these rates. We cannot find the answer yet because, who can tell me why we cannot come up with the answer yet? Receiving students? Okay, we just looked at the definition, or not the definition, sorry, but a point. Are the units the same in these rates here? No, they are not the same. So that's why it's a bit hard for us. It's a bit difficult for us to compare these rates. So what we are going to do is we have to change them into one same unit. Okay, class and receiving students. So what we are going to do is we are going to change these units or convert each rate into the same units, and we are going to use meters per second. So you get what I mean, right? We change these units, we change these rates into meters per second. And then we can compare which speed is faster. Will it be A, B, or C? So A, 9 meters per second, that's already fixed. Meters per second, we're going to use that. Okay, B, 60 meters per minute. We'll have to change this. 60 meters is already given, so that's okay. But we'll have to change the minutes into seconds. Okay, same with this one here. 36 kilometers, we'll have to change this 36 kilometers into meters and the hour into seconds, okay? And then we can compare our answers. So we'll just go through the working out together, class. So A, it's already fixed, 9 meters per second. All right, B, 60 meters per minute. Okay, this is what we did. Because 60 seconds is equal to 1 minute. All right, 60 seconds is equal to 1 minute. So I divided 60 divided by 60. So I'm left with when I cross cancel, 1 meter per second. Okay, so 9 meters per second, 1 meter per second. That's for B. Can you get what I mean? 60 seconds is equal to 1 minute, so I divide, and I have 1 meter per second. Okay, now this one here, C, 36 kilometers per hour. Okay, I have to change these kilometers into meters. So what I did was, this hint can also help you. 36 kilometers, I multiply by 1,000 because 1,000 meters is equal to 1 kilometer, right, class? That's 1,000 kilometers is equal to 1 meter. So 36 times 1,000 will give me 36,000 meters per hour. But remember, I haven't changed hour yet. So I still have to change it into seconds. So 36,000 is already fixed, 36,000 meters. Now, 60 minutes is equal to 1 hour. So what I did was, I changed this into minutes. So 36,000 divided by 60 again. Okay, so 36,000, change it into meters per minute. Okay, I'm left with 600 over 60 meters per second. Now I'm going to simplify now. Okay, when I simplify, I'm left with 10 meters per second. So you see, I already changed this into meters per second. Now you can compare 9 meters per second, 1 meter per second, and 10 meters per second. Which speed is faster? A, B, or C? C. 10 meters per second. Okay? So you see, when we are comparing rates, firstly we must change the units, or the rates must be in the same units, and then you can compare. Okay. So that working out, I'll leave it there for you to later, maybe you can copy. All right. Activity B, learning activity B, or example B, a kitchen floor requires 100 milliliters of polish per 40 square meter. What is the recommended application rate in milliliters per square meter? We just did one example already here, receiving students. What will be the recommended application rate in milliliters per square meter? Okay, I'll just give you some minutes to work this one out. Just find just do the first one first. Find the recommended application rate in milliliters per square meter. Work that one out first. Later we can go through it and we'll go to the next question. So a kitchen floor again requires 100 milliliters of polish per 40 square meters. What will be the recommended rate or application rate in milliliters per square meter? Like I said, we did an example already here. It's the same with what you're going to work out. Who's got an answer? Okay, we want to find how many milliliters per square meter. Yep. Okay, who's got an answer, class? Come on, you can just try it. All right? All right, Win?
Five milliliter per square meter.
Okay, thank you, Win. All right, Win said 5 milliliters per square meter. Anyone else? All right, we'll put his hands up here. Okay, Walter.
Ten millimeters per 4 square meter.
10 milliliters
Per 4 square meter.
4 square meter. Okay, thank you, Walter. All right. Remember, this per here means 1 every. That's it. We won't be able to bring it down again. It must be simplified to the lowest. All right. So, what are we going to do here? What number are we going to divide both quantities by? I must make sure that I come up with, this must be 1. You get what I mean? Because this has to be 1. Am I going to divide by 10? Or what number? I have to divide by 40, okay? So that I'm left with 1 square meter, because I want to find the fixed rate, okay? Receiving students, 7 is. So, just like what we did here, we have to come up with 1 cubic centimeter. Okay, so here, that's what the question is asking. Find the recommended application rate in milliliters per square meter. That's why we have this sign here, per. Per means 1, all right? Or every. So if I divide this by 40, I also divide 100 by 40. Okay, so I also divide that. So I cross cancel, square, I'm left with 1 square meter. And 100 divided by 40 is 2 what? Only 2? 2.5 milliliters. 2.5 milliliters. 40 divided by 100. 40 into 100 goes 2 times. 40 times 2 is 80. Okay, I subtract 20. Now cannot I bring down 0? 40 times 5 is 200. 2.5. So our fixed rate will be 2.5 milliliters per square meter. You see, class, just this example is just the same like this here. Remember, we are looking for the fixed rate, okay? So it's sort of like we are simplifying, or we are simplifying down. You understand? Okay. So 2.5, the recommended application rate is 2.5 milliliters per square meter. Now, if I already know that rate, how much polish is required for this rectangular floor, 8 by 10? How much polish will I need to cover this rectangular floor? The rate has already been given. 2.5 what? Remember, 2.5 milliliters of polish will cover 1 square meter of the floor. You understand what I'm saying, class, receiving students? 2.5 milliliters of polish will cover 1 square meter of the floor. Now, the question is asking, how much polish will be required for the floor, which is a rectangular floor, which is 8 times 10? What am I going to do here? Evelyn?
Mm. 80 meters.
Okay, 80 meters? 80 meters or 80 square meters? 80 square meters is the rectangular floor, but how much polish? How much polish is required to polish that 80 square meters?
120.
Okay, 120. How did you get 120?
4 times 25.
4 times 25? Okay, thank you, Evelyn. All right, Tara. Let's have Tara.
$2.25
2.25. What?
milliliters of polish.
Okay. 2.25. How did you get 2.25?
8 into 10. 8, 10.
Okay. All right. Thank you, Tara. Good try. Okay. Begley.
$1.2 square meter polish.
Thank you, Begley. Good try. Okay. All right. The rectangular floor is 80 square meters. Okay, class, 80 square meters, 8 by 10. All right, 80 square meters. Okay. Now, how much polish am I going to use to polish, that 80 square meters? Now, my rate has already been given, 2.5 milliliters of polish for every square meter. If I have 80 square meters, how much polish am I going to use? What am I going to do here? $80 times 2.5, class. 80 times 2.5 milliliters. All right? So I multiply by this, and then that will give my answer, how much polish I will need to polish this 80 square meters. So calculate, what's 80 times 2.5? times 2.5, 250, 40, 02s, 082s, 16, 1, 2. $80 times 2.5. 05s are 0, 85s are 40, okay, 02s, 082s, 16. Did you get this? Yes. All right, so point here, decimal point, so it should be 200. 200 what? Buffaloes, 200 hippopotamuses, 200 milliliters of polish. 70s and receiving students. The question was asking for polish. How much polish is required for an 8 meter by 10 meter rectangular floor? 80 times 2.5, because we already worked out the rate. 70s and receiving students, 2.5 milliliters for every square meter. So 80 times 2.5, 200 milliliters of polish. So when we are asking for the rate, that is how you should go about it. Remember, simplify until you come to the fixed rate. Okay, this is what I'm talking about. And then you can answer any other questions from there. All right. I'd like you, class, to just answer these two activities for me, please. Receiving students and 7 is solve these worded problems. Okay, this is to do with rate. So the first one is to do with comparing rate, all right, where we looked at this, and the other one is just the same as this example here. Okay, so these two exercises, 7 is and receiving students, I'd like you to work in your small groups, or you can work in pairs to answer your question. Please, if you need any help, I'd like you to raise your hands. Same with you, receiving students. If you need help, please ask your teacher for assistance. A car is traveling at 80 kilometers per hour. All right, that's the rate. 80 kilometers per hour. What is the speed in meters per hour? Okay, this time it's asking you to change that speed into meters per hour. Right? So the rate is again 80 kilometers per hour. Now you'll have to change it into meters per hour. Please, if you need help, ask. Or you have your friends there with you, you discuss your ideas. If you just sit down and you make your head blocked, you will not get anywhere. You need to try it out. If you try, you will get somewhere. If you don't try at all, how will you learn?
Who's asked a question is kilometer bigger than meter? Kilometer is bigger than meter.
So how many meters in a kilometer? How many meters in 1 kilometer? How many? 1,000. 1,000 meters in a kilometer, in 1 kilometer. So you are only going to change what? Kilometers into meters, huh? Are you going to change the hour? No. Hour is already there, it's fixed. Just the 80 kilometers into meters. Class, I'm giving you a hint now. 80 kilometers into meters. That's what it's asking for. What it's asking, the speed in meters per hour. If it said meters per minute, then you would change the hour into minutes. Yes. Very good girl. 80,000. What did you do? Divide at times. Okay, it was 1,000 what? 1,000 meters is equal to 1,000 meters is equal to 1 kilometer. So, because you are changing, you did multiply 1,000 by 80, 80,000. Good girl. Okay, good. Someone has got the answer correct. Thank you.
You want to do this?
Sorry?
I'm going to make it so. Because anyway, 8 hours can go.
You're going to change 80 kilometers into meters. Okay? 80 kilometers into meters. Okay, I gave you a hint that when converting a bigger unit to a smaller unit, you multiply. Okay, kilometers to meters. How many meters in 1 kilometer?
1,000 meters.
Yes, 1,000 meters in 1 kilometer. So if it's 80 kilometers, change it into meters.
1,000
If it's 80 kilometers, if you have to change 80 kilometers into meters, what are you going to do? times by? Good girl. Simple.
1 meter per hour.
How did you get 1 meter per hour?
80 input, 80 goes 1.
Okay, now you are going to change. You are going to change this kilometer into meter. So, how many meters in 1 kilometer? 1,000 meters. Okay, if you finish with the first one, A, you can go on to the next one, B, please. Okay, if you finish, 1,000 meters is equal to 1 kilometer. So I'm trying to change 80 kilometers into meters. And I gave you a hint up there. When you're converting a bigger unit to a smaller unit, you multiply. Can you see? If I'm to change kilometers to meters, I must multiply by what? 1,000. Okay? So 80 times 1,000 will give me meters, the amount in meters. How did you get 133? Okay. 80 kilometers. So 80 kilometers per hour. Now it's asking you to change meters per hour. You're not going to change hour because it's already there. You only concentrate on kilometer to meter. So how many kilometers? You change these 80 kilometers to meters. So I gave you a hint up here. When you want to convert a bigger unit to a smaller unit, you're going to multiply. But you must know, you're going to multiply by what? 10. Not 10. You must know your conversions. How many meters? How many meters in 1 kilometer? 1,000 meters in 1 kilometer. Okay, that's the conversion, yeah? 1,000 meters into 1 kilometer. So, because you are changing this into meter, you are going to multiply 80 times 1,000. See, to change it into meters. So, it will be 80,000 meters per hour. So, you change this into meters. That's all. Hour, because this, it's already there. Okay, that's how you got it. Okay, this one.
Is it the way to work it out?
This one is just like that one day, remember? 90 kina for 5 hours. What is her pay rate or fixed rate?
18 kina per hour.
18 kina per hour, yeah. Okay, so that's what you did. Very good. Okay, 18 kina. Where's your answer? Okay, but you must write it properly, like 90 kina. Okay, for 5. But you did the right thing for 5, and then you divide by 5. Divide by 5. Divide by 5. And then you're left with hour. And this one is 18. 18 what? Kina per hour. Yeah. Good. Okay, good. We have a group that has finished A and B. Have we finished? Okay, 80,000 what? Meters
per hour.
Okay, 80,000 meters per hour. Okay, good. And the next one, B. B is straight 18 what?
16 eh.
Okay. All right. Finish. Okay. 7 and receiving students. We'll just go through our activity. Okay, we'll go through our activity together. All right. A car is traveling at 80 kilometers per hour. All right, 80 kilometers per hour. What is the speed in meters per hour? What is the speed in meters per hour? Receiving students. Now, what are we going to do here? All right, good. Firstly, you must know your conversions. 1,000 meters is equal to 1 kilometer. Now we are going to change 80 kilometers into meters, all right? So I gave you a hint on the other side. When converting a bigger unit to a smaller unit, we are going to multiply. Now we're going to multiply by 1,000, all right? So 80 kilometers when changing into meters, it will be 80,000, because 80 times 1,000 meters. So our answer should be 80,000 meters per hour. Okay, class, receiving students, you're not going to change anything with the hour. Okay, the hour is fixed. Just the kilometers into meters. So you change that 80 kilometers into meters is 80,000. How we got 80,000? 1,000 meters is equal to 1 kilometer. We are changing the bigger unit to the smaller unit, so we multiply by 1,000. Is that clear, class? 7 and receiving students? Okay, let's look at the next one, B. Erica is paid 90 kina for 5 hours. What is her pay rate? Okay, 90 kina for 5 hours. What is her pay rate? For 5 hours. Class? Okay, good. What will we do here? Divide by 5. You divide by 5. 90 divided by 5 is 18 kina per hour. Okay? This is how you should get your answer, class. Because here you are converting. Or you are sort of simplifying. You want to get to the fixed rate. And this question is to do with comparing the rates. Okay, class, do we all understand now? Yes. All right, 7 is at receiving students. Again, when we want to compare two rates, class, we must always make sure that the rates need to be in the same units. And then we can compare rates. Okay, thank you very much, 7Es and receiving students, for your participation in today's lesson. Our key phrase for today is comparing rates. And in our next lesson, we're going to be looking at travel graphs. Thank you once again, class, and 7Es. Okay, thank you.